Hello, test. Hi everyone. So welcome to today's study section with me. My name is Funke Yusuf, and what I do on this channel is study, uh, take courses, run software, data engineering, run code, operation on data engineering, data science, and machine learning. So I am a mathematician. I study mathematics and I have BSc and MSc in mathematics. And what I enjoy doing most is studying. So this morning we will continue our study that we have started since 3 days ago. So we will continue with the part. Okay. So what we are currently studying is domain-driven design. I'm writing this book called CADABA. So CADABA is cognitive architecture design for autonomous business agents. So what we do here is I have a couple of textbooks that I need to study to write this book, and domain-driven design is one of them. So I just want you guys to study with me. Please, if this is your first time on this channel, please kindly like and subscribe. Okay, so you can hear from us next time when we come up. And today we'll be looking at part 3 of the book, Domain Driven Design, published by O'Reilly. It's a very fantastic book anyway, okay. So we've done part 1 and part 2. So today we want to look at part 3. And of course, so part 3 says applying domain-driven design in practice. In part 1 we look at how you need to work with business experts, business owners, to understand the business problem, because the business owners know the business problem best. So you need to gather requirement. So everything that was done in part 1 is requirement gathering from the business owners. And then in part 2 we look at architecture pattern. How do you design architecture based on the domain and the subdomain, and how do you design communication pattern? So we look at out of the box communication, we look at Saga, we look at CQRS, we look at event-driven communication and event-driven design pattern. We also look at synchronous and asynchronous and all that. So I believe you have core understanding of them now. And under architecture, we look at how you can design layered architecture for specific domains. So architecture is layered. You start from the UI, user experience, you start to your application interfaces, to your applications, uh, and then to your everything, to your backend, to choosing your databases, whether you need to use relational database or non-relational database, and everything. So it follows a layered architectural design pattern. So let's look at what we have today. Domain-driven design, part 3, applying domain-driven design in practice. So we want to look at designing heuristics. So after this chapter, studying this chapter 10, you understand what is meant by heuristic and how to design it in particular for specific domain. So let's get to study. We'll study, then after studying and taking notes, we'll come back and explain it together. So all right guys, so let's study chapter 10. Studying this chapter 10, you understand what is meant by heuristic. All right, guys, so let's summarize what we have learned in this chapter. So in this chapter, we looked at designing heuristics. So this actually talks about, you know, choosing architecture based on business complexities. Remember, in our past study, we said that if the business is simple, design simple architecture. If the business is complex, design a complex architecture that meets that need, and also design based on the business subdomains. So what this chapter is telling us is that heuristic guide design but do not replace judgment. So heuristic does not replace critical thinking and evaluation. It does not replace, designing. Heuristic should not be intuition. You should not just think, okay, since this business look like it, let me look for this should work, layout architecture should work. Oh, if I use the script I use for business A for business B, it should work. No. So heuristic does not eliminate critical thinking and judgmental design. So we should take business complexity into consideration when we are designing application. So start on certain core domain with wider boundaries. Remember, we have a boundary context where we say every domain operates within a boundary. And if a domain will interact with another domain, it should interact via a contract. There should be a defined contract where they will interact from. So uncertain core domain with wider boundaries. So if a domain is uncertain, if a domain is unbounded, what you can do instead of operating within a predefined boundary, or instead of defining a boundary, a bounded context for it, is to enlarge the boundary. So it can be interconnected. So you can enlarge the boundary, you can enlarge the domain to other domain via a contract. So match business logic pattern to actual domain complexity. So all business logic should match to domain complexity. If you are using event source, make sure it match domain complexity. Let your transaction script match domain complexity. Let your testing, whether integration or unit testing, match domain complexity. Let the implementation pattern challenge the subdomain classification. So everything you want to implement, let it also align with the subdomain classification. Take every classification in the subdomain into consideration when you are designing. Then advanced architecture without business need creates accidental complexity. So do not advance the architecture when the business does not command it. So maybe because the business will expand in the next 5 years, you want to design an architecture for that expansion now. No, design based on what it is happening now. Then you can scale up. When the business expand, you can scale up. Then if it's come down, then you can also scale down. So we have vertical and horizontal scaling, so which allow for this capability. So this is how you can use design heuristic or heuristic pattern in your designing. So how does this apply to CADABA, agentic system design? So when you are designing agent tool, remember we said that you should select agent based on the subdomain. So agent that work for procurement cannot work for IT operation, for instance. So you are designing specialized agent for each business subdomain, okay? And then when you are selecting pattern, select pattern for agentic system according to the business complexity as well, and the risk that is at hand. For example, the level of risk that you want to design for in financial agent, for instance, it's not the same risk that you will design for in IT operation. Okay, so you will let the risk, you will let the governance and policy implementation in the financial agent be very high than IT operation, which is just a metric and monitoring of applications. So CADABA should accept pattern according to business complexity and risk rather than declaring every capability agentic and event source. So it is not all capability that are agentic. Some are just ordinary workflow or that you can implement. You can build simple workflow, maybe logic app or Power Automate or Power App can solve most of the problem. So you don't need agent for that. And where you or where a business is simple and require a simple model, a simple agent, do not design complex agent. For example, you may need just one agent to solve a problem. If you design multi-agent system in that pattern, you'll be, optimizing cost, which is not the best thing for the business. So simple data injection, uh, if the data injection is simple, design simple transaction script. For agent configuration registry, use active record. For policy control autonomous workflow, for instance, use domain model. For regulated decision history, use event source domain model and CQRS. So this is how you can go about it. And when you are also designing for testing, do not design a general test for all agents, because why their specialization is different. So make sure you design unit testing for each agent. Test each agent individually. Then you can now start integration testing as well. Do unit testing for individual agents. For your modules, test your modules, test your function. That's unit testing. Perform integration testing for each agent to see how they integrate with the adapters that you have designed for them to connect to the business applications. So autonomous workflow requires scenario evaluation. So red team cases and end-to-end simulation must also be put into consideration. So this is what we have here. So heuristic does not replace critical thinking. It does not replacing matching a particular design pattern to a particular business domain. And it does not says that you should design a very complex architecture ahead of a business that is just expanding. So design based on the business complexity that is at hand, and then when the business expand, you can now scale up. All right, that is that about chapter 10. Now let's look at chapter 11, guys. So be very fast today. Chapter 11, evolving design decision. We are studying now. All right, guys. So in chapter 11, it talks about evolving design decision, just like building on what we have learned in chapter 10, heuristic, uh, designing based on choosing pattern based on business complexities, or testing based on business complexity, transaction script, model, data model based on business complexity, and making the application, the pattern simple when the business is simple, and design for complexity when the business is complex. Now, in chapter 11, it talks about evolving design decision. So this is just like what we previously talked about, that, well, you should design based on what the business, where the business is currently. Design, if you want to design a database, design based on the data that is currently available, and then you can now scale up when the data expand, when the applications or the system expand. So point number one from our handwritten note: business organization knowledge and growth continually change design needs. So you remember, business grows. A startup today can grow and become times three, maybe by next year. So if you want to design an application for a startup that is starting today, you also put in, a room for it to scale up when it expand in the coming years. So subdomain can move between core, generic, and supporting type. So as you design earlier, as we studied here, so look at this point here. Pattern can evolve progressively. You can move from transaction scripts to active record. You can move from active record to domain model. You can move from domain model to event source model, for instance. So you can move from those approach. So subdomain can change type. So look at this point here. Subdomains can also change type. For example, it can change from core to generic, which a formerly unique capability become commercially available. It can also change from generic to core. The organization builds a differential replacement. Supporting to generic, a suitable product become available. Supporting to core, optimization creates competitive value. Core to supporting, complexity is removed because it no longer pays. Generic to supporting, integrating a product cost more than a simple internal solution. So these are things that you should put into consideration. And then the test also says that, you know, when application complexity, when the business complexity expand, then you also need to expand your staffing. You need to expand your engineers, expand your developers, expand your support staff. For example, a support that has been supporting one application for the past 5 years, who has now known the in and out of the application, can be, moved permanently to become, a core staff that will be supporting that application continuously, because now they know how to use it. So increasing implementation pain signal and outdated model. So do not just increase implementation pain. Anything that you have to maintain continually, then it's becoming outdated. So that means you have to update you have to update the model itself instead of just paying for implementation. So anything that you implement maybe beyond a year or to 3 years, then it's becoming outdated. You need to redesign it. Evolve pattern incrementally instead of making one large job. So do not just say, oh, because the business application, the business complexity has radically increased, you just want to jump from, maybe implementing one virtual machine skill set to like 10 virtual machine skill set. No. So evolve pattern incrementally. Make sure you evolve gradually as the business increase gradually. Do not wait till when everything is down, when the application is down, when the database is down, when nothing is flowing in the business before you design. No, make sure you notice every change at every step, and then scale as the business grow. Scale incrementally instead of radically. Reassess subdomain context and aggregate as CADABA grows. So also, when you are designing agents, how does this apply to agentic system design? For example, you have a simple, you are running a startup company. You just need a simple, maybe finance agent. You have procurement, finance, supply chain, for instance, and everything. And then you know there are 5 agents that you can design for procurement, 5 agents for finance, 5 agents for supply chain. And then you want to deploy all of this at once when your business has not yet require it. No. So make sure you start with one simple agent. Then you can now increase to 2, to 3, to 4, to 5 as your business, as the business use case expand. So that is how you design. You design gradually. You can ship a single agent, pilot agent, let people in the industry, in the company test it. When they test it and it is good and it satisfies the requirement, then you can now increase to 2, to 3, to 4, to 5 when it is capable and stable. So CADABA must expect models, tools, and cognitive capabilities to change classification. Foundation model inference may become a generic commodity, while CADABA's domain adaptation, memory policy, reasoning, and workflow recovery remain core. So a basic agent workflow may begin as supporting scripts, but evolve into a core cognitive process once it accumulates learning, exception handling, and optimization rules. So its architecture must then evolve rather than forcing new complexity into the original design. So allow architecture to evolve and then scale along as it evolves. So CADABA should also monitor architectural pain through change lead time, duplicated policies, coordination requirements, exception rates, and failure caused by inconsistent agent system. So this is what we have learned in evolving design decision. So scale up as the business evolve. Do not just wait till all the business applications are failing. Do not wait till when the business is stagnant and nothing is flowing before you redesign. Design gradually, or increase design gradually, expand design gradually as the business evolve. So that is that about chapter 11. Now let's move to chapter 12. We'll study for like 5 minutes and then we'll come back to summarize. All right, guys. So this chapter still talk about requirement gathering, which is event storming. Okay. So event storming is just like gathering all the stakeholders together and then brainstorming on the requirements. So I remember when I was working at Infineon Technology, we normally do this thing when we want to modernize a legacy application, or when we want to perform an application migration, or when we want to design an application from beginning. So that's when we normally do event storming. So according to this book, that is what this book also explains. So event storming can be done when you want to build application from scratch, when you want to modernize legacy application, when you want to build, a data engineering, data platform from beginning. So it can be done when you want to build a platform, data platform, build application from scratch, or modernize a legacy application. So this book identified 10 event storming steps. So what are the steps of performing event storming as a software developer? Remember, event storming is not only for software developers, it is for everyone in the business. Okay, so it is for everybody. The business developers are there, engineers are there, operation teams are there, business experts are there, security teams are there, networking teams are there. All the organization, all the stakeholders must be present. So we have unstructured exploration. So this is where participant independently separates past tense domain event without initially worrying about order or duplication. So they separate past domain from the current domain. And then we have timeline. So events are organized into a successful path and alternative or failure path here. And then we have pain points. This is where you gather bottleneck, missing knowledge, manual work, inefficiency, are marked explicitly. So you can get pain points. You can ask the business owners, those who are the owner of that business, what is their pain points. Then when you can transform the pain points to, a solution that application can solve. Then pivotal events. So important changes in business phase or context are identified here. We have commands where imperative actions that produce event are added. We have policies, which is event to command automation rules, and their decision criteria are modeled here. We have read models. Information actors need before deciding to issue a command is identified. We have external system outside the explore domain that trigger command or receive event are added. We have aggregates where related command and events are organized around consistency boundaries. We also have bounded context where related aggregates and policies are grouped into candidate model boundaries. So these are the 10 steps of performing event storming, and then you can apply this in your next architecture design or application development. So the process can be adapted. So a broad session may first discover the entire domain, followed by detailed session, and then use event storming for complex or uncertain process. So you should use this. You don't need event storming for all application that you are developing. If you are developing a simple application, maybe that composed of 2 to 3 engineers or so, you can do daily stand-up instead of event storming. Event storming can be 1 or 2 a week, and it should be done when you are designing complex or uncertain business process, where you gather all the domain experts together, all the business experts, all the business owners, and then all the engineers and the developers and the security engineers are also present. So it is useful for developing a ubiquitous language, discovering requirements, recovering legacy knowledge, onboarding team members, and improving operations. So you should perform event storming when you want to discover requirement, when you want to gather requirements, where all the domain experts will be present and all the specialized engineers and developers will be present. You can perform event storming for that. And then when you want to recover legacy knowledge, as I have said, when you want to redevelop legacy application, perform event storming. When you want to onboard team members, perform event storming. When you want to introduce all the team members to the to the problem that they want to solve, to the development process, you can perform event storming. When you want to also improve operation, you can also perform event storming. So do not force it onto trivial workflows. A simple sequential process with no meaningful rule may not justify the workshop. So facilitation matters. So you need a software or software architect that will facilitate everything and notice every interaction, include quieter participant, monitor group energy, ask questions, and record conflict without suppressing them. So monitor the group energy, monitor the energy of everyone present in the room, monitor the interaction of the business owners. Also note how they answer questions when you ask them questions. Also note how they interact when they talk about their pain points. So remote workshop require more patience. So if you have workers that are working, if you have members that are working remotely, for instance, you should exercise patience. Maybe you can organize small group. You can, instead of putting every like 50 people together in a one team meeting, you can create a breakout room, or you can group the meeting into like five, where you have like five teams, subgroup meet together and go to specific domain to gather requirements. So instead of gathering everybody together, you can divide teams into like 5 or 10, for instance, and then each team will go to a particular business subdomain to gather their requirements, and then they come together again and combine everything together. So small groups, multiple sessions are often more effective than one large virtual meeting. Okay. So for CADABA, in agency system design, event storming should proceed the design of important CADABA agent workflow. For example, if you want to design a procurement workshop, for a procurement agentic workshop, events review what actually happens. Okay, command identify candidate agent action, policy review deterministic automation rule, or read models, identify the evidence agent and human need, pain point review automation opportunities and risk, aggregates review consistency boundary, bounded context review specialist agent responsibility. So these are ways you can use effect storming, for example, when you want to develop a procurement agent. All right, so this is our 5 handwritten notes. Event storming model business process through domain events. So it's model business process through what we call domain events. Domain event is just a gathering of engineers, business experts to develop to explain pain points and to discuss about the application and why it is needed. So its greatest value is shared knowledge and language, command policies, read models, explain how decisions happen, pivotal events and aggregate suggest system boundaries, and model the business process before choosing agent. So always make sure you model business process before choosing agent. Okay, so event storming is very, very particularly important before you design agent for a subdomain in a business enterprise. So that's that about chapter 12. Now we'll move to chapter 13. Please, if you are just joining us, please kindly subscribe and like. And we do this every day. This study every day. We come a little bit late today. So it's normally around 5 a.m. in the morning. So you can watch out to join along. Thank you. All right, so in chapter 13 says domain-driven design in real world. So how do you perform domain-driven design in real life? So that's what we are talking about here. So look at our 5 point and written summaries. DDD works in brownfield system and it's not all or nothing. So DDD is not the, you know, it is not all or nothing. It means that it is not all that is required for you to develop an application, and it is also nothing that you can do without. Okay, so you cannot do without it, and then it does not finalize the development or the success of your application or system design. Okay, so that is what it means by that. And then it went through all the reason why you should adopt domain-driven designs in your architectural, in your application development, and then when it is necessary. So modernization begin with business and architecture analysis. Okay, I have said, like we have discussed in the previous chapter, chapter 12, we said that DDD is best, or event storming is best done when you want to design application from scratch, and when the application design involves the entire business, and when you also want to modernize an entire application, and when you want to develop a platform. For example, you want to develop a data model for the entire business. So event storming is needed. So now in real world, so you should also implement domain-driven design when you want to build a in data engineering, when you want to build a data platform for an entire organization, for an entire business. You should implement domain-driven design. But if you are building for a particular subdomain in that business, you don't need domain-driven design. You don't need to gather all the domain experts. No, you need just that subdomain that you are building for. So when domain-driven design is useful when you are modernizing legacy system, and when you are building application from scratch for entire business. So modernization begin with business and architecture analysis. So if you want to modernize, you have to gather requirement from all the business domains and experts, and then you also have to analyze the legacy architecture before you now modernize it. Align logical model before extracting physical services. So make sure you look at logical models. Logical models are, how the application communicates, how the application interact together, and the logical model is also the, data model, how you design the business logic and the rules of getting data from each application and storing them in the databases. Use strangler migration instead of a dangerous big rewrite. So do not rewrite a legacy application because it is old. You can use strangler migration. You can gradually migrate it to a modern application instead of just rewriting it entirely, which can disrupt the business. So for how do you apply this when you are building agentic system? Introduce CADABA gradually and prove each autonomous capability. So do not just build 10 agents at once and deploy it into because you're an expert, or because the business say, oh, we need agent. No, introduce it gradually. After you have performed event storming in the whole organization, each subdomain, you know their pain point, you know their business requirements, you know the policy guiding their implementation and everything. Then you can now introduce agent gradually. You can build one agent, then if it's give them for them to organize a pilot team. If the pilot is successful, then you can now increase it to 2 to 3 to 4 to 5, and make sure the governance is tight. Okay, so a monolithic prompt-based enterprise assistant should not be replaced through one large CADABA rewrite. Okay, so a safer approach is this. So when you, for agentic system design, a safer approach you can take is analyze the business workflows, establish ubiquitous language, identify core supporting and generic capabilities, create logical domain models, or put anti-corruption layer around legacy APIs, run selected CADABA workflows in shadow mode, or compare outcome before gradually moving production traffic, and retire legacy component only after the new capability is proven. So this is the method that you can implement. When you want to apply domain-driven design into a agentic system design, for instance. So chapter 5 is just like a summary of part 3, domain-driven design in real life. How to put what you have learned, event storming, business requirement gathering, interaction, communication pattern, architecture pattern, how you can apply them in real life when you are modernizing application and when you are building application from scratch. So this is the end of our study today. I will schedule for tomorrow now, and then we'll come back tomorrow by 5 a.m. or 4:30 a.m. To continue part 4. Part 4 is a relationship to other methodologies and patterns. So how do you relate domain-driven design to microservice architecture, to distributed systems, to cloud application architecture, or to software architecture design entirely? And as a software architect, how do you apply domain-driven design in your practices? Or as a data engineer, how do you apply domain-driven design in your or data platform or development? So this is what we'll be looking at next, chapter 14, microservices, and so on and so forth. So see you tomorrow, guys. Bye. Thanks for joining. Please like and subscribe.